All right, we're getting towards the end of the semester, and I hope everyone's hanging in there. I know it's hard to kind of keep energy going this long semester. I was telling Jessica there, my undergrad, I went to school had quarters, so it was like 3 quarters during the main school year and a summer quarter. And actually, it was pretty glorious because all the classes were like 10 or 11 weeks long, and so just when you start to hit that point where you're kind of done with the topic, you'd be done instead of hanging on like another 4 weeks here. So anyway, almost there. Keep going. All right. So last time I started talking about this k-nearest neighbor classifier, and then started getting some sort of complicated generics aspects. And the main thing that came out of that, remember, was like if we had a class. What did I want to do? We had the generic part where we had E extends sample as the generic. So instead of just the usual generic E here, we could make a restriction on the kinds of classes that could go into E. And we're heading down this path to kind of make all this stuff work together, where we have samples in the k classifier, and then things inherit from sample, and it was all going to work really nicely. And I sort of kept working on it, and I suddenly thought, I don't want to dive down this rabbit hole quite as much, because we're getting stuff like class sample, T extends sample of T, and implements comparable of T. And you can parse this. I mean, this basically says T inherits from a sample superclass that happens to be generic by the subclass, right? That's really actually kind of weird. So like this is being defined in terms of this, but this is defined in terms of this. And then we want to look at comparison. So we could have spent like all lecture talking about this, and I thought, you know, let's just make life a little easier. So we're going to have a sort of simplified K9 classifier and GUI, and it's going to be a little easier. So anyway, I decided not to go push that much more. We'll probably be doing stuff like that in 2420 quite a bit, so that's sort of my original motivation for showing some of that stuff. But I think given the amount of time left, we need to sort of wrap this up and do something a little simpler. So today, talk about how to implement the KNN code a little bit more. You get some assignment materials out today just to get started, and then there's sort of be another wave of the full specification on Monday after I talk about some GUI drawing stuff. So we need to know how to draw things on our GUI window instead of just drawing images and things like that. So a little disjointed, to be honest, but nothing too crazy. And I'm going to try to keep the scope of all this pretty sane for the last week and a half of the semester here. So anyway, I'll have a sort of a fake assignment out today. This is one of those optional partner assignments, and again, it'll be nice to get started on that process. There's some code to download, some stuff you can write over the weekend if you want to get going. But the main thing is the rest of it's coming out on Monday with more of a graphical interface part. So let's talk about it, and then we'll see if there's any questions at the end of class about how this is all going to unravel. All right. So let's review quickly k-nearest neighbor classifier. So we have some kind of thing we want to classify, right? And that thing in this case is fish. But we also, we're going to do fruit, and eventually we're going to do face expressions, like we had that little Kahoot quiz at the beginning of class last time. If we can turn this thing into some numbers, then we can kind of get it in the computer, basically, and represent it in some kind of space of samples. So this is a 2D space of samples, and the two kinds of fish are plotted here as squares and diamonds. And if you have an unknown fish, the goal of the k-nearest neighbor classifier is you measure the distance to all the other samples. And again, that distance is some sort of abstract distance, basically the difference in their measurements, the distance in their attributes. So, I can say I'm different, my distance to you is based on the difference in our height or something like that, right? That's not what we think of as distance. Like, we think of distance as a physical moving across the floor kind of quantity, but mathematicians think of distance just as differences in measured attributes. So we can get a distance to all these samples. We pick the closest k, in this case it was 3, and then we vote on which one is the majority nearby classification. In this case, there are 2 diamonds and 1 square, and diamond means salmon, so we're saying this unknown thing is a salmon. All right? So basically, conceptually, I think this algorithm is pretty easy, which is, I think, attractive about it. Like, you can implement it, you know, after a semester of Java kind of thing without too much trouble. And it has value. People still, you know, use this to classify things. It's not the most sophisticated thing, but it does a pretty decent job. Okay, so questions, basic idea. Anything? Clarify? Okay, so that sort of hand-wavy pictorial visual description can be encoded a little more formally, right? So we want to start with a list of known samples. Those are all the fish that we know about, that some expert has gone and said this is a salmon, this is a sea bass. Then we get an unknown sample, and the computer looks at it and measures its attributes. And then we want to find the distance between the unknown sample and all the other samples, sort the known samples by distance. So that's actually sort of the one. So here I said, oh, find the nearest 3, right? What does that mean? Well, we know how to find like the smallest value. We know from like our list patterns, we can do an optimization loop and find like the minimum value for distance. But it's a little harder to figure out how to sort of translate that into like the 3 closest or 5 closest. And so the more general way of finding the k closest things is to sort all of them and then just pick the first 3 or 5 or however many there are there. So that's sort of the general way to solve this problem. And then we want to pick the k nearest and then have them vote and the majority wins. All right, so let's look at each one of those steps and see, like, can we translate that English into some sort of at least Java concept here. So if I say start with a list of known samples, what kind of thing is that? How do we get some collection of things stored in the computer?
Array list?
Yeah, an array list, probably array list because we don't know how many of them there are. Now the weird thing, so I might have something that looks like, actually let's make some, I want to do some code here for a second. All right, so, let's make an array list of integer for now. Int equals new array list integer. It's empty to begin with, and I have to import in array list. All right, so this is the way we've been using this, and you can say, of course, ints.add 4, and that int4 gets boxed up into a capital I integer class automatically by that weird Java thing that's going on, and stored in this ints array, right? So there's like a lot of little subtle things going on here, but it looks pretty straightforward. Now, we've been showing it this way. A more common thing, if you start looking at code, is you do this. And it complains to me for a minute. All right, so here I have list of integer equals a new array list of integer. What do you think is going on here? It's like, what is a list is the first question, right? Any guesses? It must be something for this to work. So what must be true for us to assign an array list to list?
List must be the parent class of array list.
Yeah, array list must inherit from list, because through this polymorphic property, the more general class can reference more specific objects, right? So in this case, somewhere there's going to be class list, and then there's going to be a class array list extends list. Now that's actually not quite right. There's another possibility here. What's the other possibility where this would work? So array list inherits from list, so we can have a list reference a array list object, but there's one other possibility here. Yeah, this could be an interface, right, where there's no actual code here. It's all abstract stuff, and then this implements. All right, so we're allowed to do this because, again, the more the superclass, the parent class, the more general class can reference the more specific thing. But one question is why? Why would I want to do this? Right?
So that ints would be now defined as a list object, not an array list object?
Yeah, well, that's true. So ints think they're a list. The object knows it's an array list. But why do this sort of like switcheroo kind of deal here? This is sort of strange, right? What do you think? Yeah.
Does it have to do with the types you can put into an array list and a list?
They both are generic, so they both can put in anything.
Is it so that we can pass it to methods that take lists and it thinks it's a list rather than...
Well, that's one idea. Like maybe there's a... something like this defined. Yeah. And we want to be able to print out sort of in the most general way any kind of... The real key here is that there's no reason to do this unless you know more about lists. So for example, along with array list, there's also linked list. And both of those inherit from list. And as I'm writing my code, I may start off doing an array list, and then I might have something that makes a linked list a more efficient implementation for what I want to do. And so if I were putting everywhere here array list, and then I decide, this linked list thing, which we don't know anything about at this point, but maybe it's for some reason a better choice for my implementation here, then I would have had to go through and everywhere I had array list, change it to a linked list. If I create it like this, then the only place I have to change it is when I make that list in the first place, and everything else is this more general list here. So it would be list integer, list integer, list integer, list integer, list integer. I create one linked list, and all my code stays the same.
Do they share enough methods where you wouldn't have to change?
Now do they share enough methods? Well, they both actually implement list. And list defines this contract of what kind of things they should have. And so they really actually implement basically the same thing. It's their internal representation that is different. So that's the advantage of having these interfaces, is that if they all inherit from this interface, then you can be guaranteed that they will work in certain contexts the same way. So anyway, that's, again, that's sort of like a bigger system kind of question where you're developing something, you want to keep it easy to maintain, and this is the kind of thing you see to keep it kind of easy to maintain. That if I store things in general things, then I can just change how it's created and everything else still works. Okay? At the very least, you'll see this in code examples online, and so you shouldn't freak out when you see it. Just realize it's an example of this kind of thing here. So, any more questions about that? Again, it's sort of this. It's not wrong to say this, right? In fact, we've been doing it a lot. But it's better in a software engineering perspective to do that. I still find it hard to do it like this way myself, to be honest. I think it's sort of, I'm just not used to doing that.
Does that add method add the integer 4 onto the end of the list?
It adds it on, it expands the array as necessary and adds it to the end of the list.
So I guess to say that you want to define object in the most general class possible that still fits all your functionality, is that kind of that?
Yeah, we want to reference it to the most general thing we can to allow future changes underneath.
So when we do that, when we say, hey, what are you? It says, I'm a list, but then when you go inside and it says, I know that I'm a list, but I'm an array list because I can do all this stuff.
So when it compiles, it thinks it's a list, but when it runs, the object it points to knows that it's an array list or linked list. And so
it does all the methodology.
The implementation of all these things defined in the interface are different for each of those classes. Kind of like we had our dynamic array 2 classes, right? We would have wanted some general DA class that defined the interface, and then both those classes derived from it, and you could swap those two sort of interchangeably and get different performance as desired. Kind of things. All right. So it's subtlety, but CS is full of a lot of these subtleties, to be honest, and the difference between like a good developer and someone who just is like barely writing code, you know, is this kind of stuff. And so just be aware of this kind of stuff, I guess. Okay. PowerPoint. Click. Okay, list. Yes. Yeah. So, and again, we only know about array lists, so this doesn't seem like a big issue, but when you know about 5 different kinds of lists, then you're choosing between them for their performances, and this kind of decision makes more sense, right? If you only know one thing, then there's no point in keeping it general. If you know 5 things, then keeping it general is better. So, okay, that's one. We know how to store our list of samples. Number 3, I guess we skipped 2. What was 2? Get the unknown sample measure attributes. That's some actual, you know, physical measuring of things or computer measure of things. So find the distance between the unknown sample and all the other samples. So I said the distance, again, is the difference between the measured attributes of the samples, usually in the Euclidean distance, which is the same as the square root of the square of the differences of all the attributes, the Pythagorean theorem. Since we have to access those attributes to calculate the distance, it kind of makes sense to put this distance calculation in the sample class, right? So a sample knows about its attributes, and those are probably private instance variables. And so we want to have this distance be some sort of method in the sample class. Now we need to measure the distance between a sample and all the known samples and this unknown sample. And it's sort of weird to do that at the sample class because the sample class is defining a single thing. So probably in the classifier class, we want to have some code that loops over all the samples. And this is that for each loop notation we just sort of showed briefly. I don't know if you're using it at all, but for this list, pull them out one at a time and put them into S. And then on S, invoke this method, call this method calculate distance to the unknown object, right? And this is probably we're going to store the distance in this S object here. So we want S to know about its distance. We should know about its attribute, it should know about its classification, and eventually it should know about how far away it is to this unknown thing. All right, so that's something that's, you know, we're just looping over stuff, no big deal, pretty easy. And we don't need to sort the samples by distance. Now this is where you have to kind of think a little bit about how to make this happen. So again, we could have collected all the distances in some kind of array list and gotten a list of distances. And it's actually easy to sort an array list. There is in the collections class a static method sort that sorts in place. In other words, it doesn't return a new array list. It just modifies the current array list of distances. So let's say for each sample, I measure the distance, put it into this distances array list, got our list of distances, sorted it. That would tell me, you know, 0.07 is the closest one, followed by 0.12 or 1.2, and so on. What's a problem with this for what we need to do? So we have our samples, we're trying to measure the distances. Can I just put them in a list like this and then progress, or what, you know?
You need to match the type, like the labels that go with it to the distances themselves. So when you sort it, you're only sorting the distances and not the labels as well.
Yeah, if I sort this, I don't know what sample this belongs to anymore, right? So I don't know the classification that it belongs to, and so it doesn't really help me just to sort the numbers. Were you going to say something different, or is that?
No,
that's basically, yeah. And this is the classic kind of problems, like where do you hold the information so you can actually work with it and get the answers you want out of it, right? And so, you know, you pick up ideas as you see these things happen, but this is a very common problem. I have some data I want to organize things by, but there's this whole other bunch of data that should go along with it, and that makes it kind of tricky. There are approaches that, for example, will give you a permuted index array as well. So if you start off with this being index 0, 1, 2, 3, 4, and you sort it, as a side effect, it can also turn back a new array that sort of says how these things have moved around. So that's one possibility, but kind of awkward. Yeah.
Collections, is that a method, well, sort, is that a method that's part of the array list class, or would we have to import that?
So collections is a, well, probably an interface.
Okay.
But in this case, well, it's a static, I don't know, anyway. But this is a static method in that, maybe it's an abstract class, right? You know, Whether you have to import it or not, I can't remember, you know.
That's right.
Whether it sort of happens or I've done it before, you know. Anyway, you probably got to import it. All right, so the problem is that we can sort distances, but we need samples to move along with it. What's the answer here? How can we make samples know how to sort themselves? We've actually done this once in class.
Is it the dot compare method?
The what? Compare?
Compare method?
Yeah, so you may recall very briefly we have our class sample. And we want to be able to sort objects of this type. And it has some instance variable in it, like double distance. We want to somehow sort objects by their distance. We need to implement comparable of sample. All right, so this says there's an interface that exists. It happens to be a generic interface. In other words, you have to specify what type it's an interface for. And we want to create it for our current class where we're going to compare one object type sample against the other. Okay? And it's the whole thing where we look at the distances, and if they're the same, you return 0. If I always forget the order, the first one is smaller than the second one, you return -1, and if it's bigger, you return 1. That's because it creates that you have to define the compare to method, and we use that in strings, right? That if they're the same, it was 0, and if they're lower alphabetically, it was -1, and so it's that same thing. If you go back and look at lecture 32, there's a way to do that. So you can be wanting to do this for the K&N classifier, so we can sort samples and get an array list of samples that are sorted by their internal distances, not by some external number that we have to provide. Okay. So, and then you can call collections.sort on a sample list, and it will sort them by that, however you specify it should happen according to this. So look at that. All right, so we've sorted them. We want to then pick the nearest k of them. That's actually pretty easy. There's just a nice method on list that says give me a sublist, and you can start from the beginning and go forward 3, and they'll make a new list that's that size. So one call to kind of pull off these shortest ones. And now we get to the hard part. Now we need to figure out what is the majority classification of those nearest neighbors. So let's think about this a little bit. So after all this work, we started with a list of samples. We calculated the distance from all of them to the unknown one. We sorted them according to their compare to method that we implemented. And then we pulled off the bottom 3, if k was 3 in this case. So we might end up with something like this. Our k nearest array list, or list, has 3 objects in it. One sample that says, this is for fruit, that says orange, and it's a distance 1.3. The second nearest is also an orange, that's 1.7. And then there's an apple that's 2.1. So in this case, what would we say the unknown classification is? It's an orange. It's 2 to 1, right? The majority wins here. So how would you write code to do that? That's the tricky thing here, all right? I want you to spend like 3 minutes talking to your neighbors and see if you can kind of hash out some approach to doing this. You know, we know how to find the maximum of things, we know how to count things, we know how to do some of this stuff, right? So I want you to just talk for a minute with somebody and see if you can sketch out some code that would kind of do this. It's not a lot of code, but it's actually there's some subtle issues here.
I feel like that's
All right, let me hear an idea about this. How would you count up how many oranges are and how many apples there are? All right.
Move through each instance and have a variable for apple and orange, and each time it pairs, we increment that one counter, whichever has the most.
Sample S in the K-set. And what do you want to have happen? I'm sorry.
You do like a count, initialize an int that's an a count,
Apple count,
orange
or
count.
apples, I'll just say. Oranges. All right, so we don't have any apples, we don't have any oranges. We look through and
We'll say for each instance, we'll say if, and then if it's one of them,
S,
dot
I'll call it class for classification,
equals orange, or dot equals orange,
equals orange,
then we increment orange,
and oranges
plus
plus,
else.
and then apple.
Can we just do else? Assuming there's only.
Oh yeah, else, yeah. Only two things we know about. Else, apples, plus plus. All right, so that's kind of workable. Well, let's say this is actually not a Canadian classifier, but a, let's see, who's the company that makes like voting machines? I don't know, I can't remember. The ones that are hacked, you know. What can you do in voting for a candidate that's not represented by this? So you go in there and there's the people on the Democratic Party, and then there's like the Green Party, and the Republican Party, and the Libertarian Party,
That's my.
and the American Freedom Party, and these things. But what else can you do?
Right in.
You can do a write-in vote, right? And so here we're saying there's two candidates. There's orange and apple. Which one is it? And it's encoded into our logic here. But there's no chance for like a new thing to appear in this list. And maybe I want this to work more generally where, you know, I have a text file that says orange, here's its weight, here's its circumference, apple, here's weight, here's circumference, and all of a sudden I want to throw in a banana or a grapefruit, right? And I want to make this thing still work and I don't want to have to go back and redo the code every time I add a new piece of fruit to this classification system. Because this, you know, the K&N classifier is not just an either or choice. It's not always out of two things. It's like there could be 10 fish we're trying to classify or 20 kinds of fruits or something like that. So I want to keep it a little more general. So if you didn't know these labels in advance, can we still, how, you know, we can't compare to a known thing then, right? What could we do you think? Yeah, so we haven't really, that's what I'm going to talk about really, but I'm just, you know, still, given like an array list, could you come up with some kind of solution? What would you do?
Well, instead of creating an individual int counter, I would probably create like an array list of, and call it my classification array list, that loop through how many samples and say, hey.
All right, so you have an array list of counters.
Yeah.
And then every time you found one of these things, you would stick it on an array list of labels.
Right.
So you could go through, you could like pre-process it all and say, what labels do I know about? Orange. Is orange in my labels list? No, let's add it to the array list. Is it, you know, So you could kind of make up something where you're kind of keeping track of all, go through once and kind of see what the different labels are, stick them in their own array list, make a counters for all those things that match up between labels and count, right? And then you go through again, and then you say, okay, is it one of these things I found? What index am I at for the labels? And then add to that counter, right? So you can make it work.
Probably do it in the same loop though.
The same loop, yeah. So there's some way we can kind of make it work, but we're sort of handcrafting this association between the counter and the label. And I think it's kind of prone to making some errors there. So it's a little bit sketchy. So let's try something else. And that is a map data structure. So we've been using lists, and the implementation of the list we've been using is the array list. And map is another sort of general data structure that also stores things, but in some ways it doesn't store singular things. An array list holds a whole bunch of somethings, right? A whole bunch of fruit, a whole bunch of integers, a whole bunch of whatever you want. A map stores relationships between two things. So you could have a map holding a string and a value. So like a UID or something like that, right? No, it's not code, so don't. It could also hold a number and a string. So it holds these pairs of things. This side, the left side, we call the key. And it's sort of the thing that accesses into the map. And over on the right side is the value. And the value is what's stored at this key. So you give it a key, David, and store a value to associate with that key. You give it a key, 100, and you store a value to associate with that key. All right? Now, an array you can kind of think about in the same way. An array, or a list, or an array list really, has an index and a value associated with it. So you give it an index, like 1, and it gives you a value. A map is a generalization of this, where this kind of thing can be anything, like a string, or another object, or all sorts of things. So let's make some of this. All right, get rid of this. So I want to make a map, and to specify a map, it's a generic class, and you have to say what type is the key and what type is the value. So I'm going to say that I want my keys to be strings, and I want the values to be integer. All right, so in an array list, we had to only specify one thing, the type of thing that was being stored in the array list. And that's because this index is always an int number. Now there's sort of two halves. There's the type of the key and the type of the value. Everything in this map has to match that pattern. String, integer, string, integer, right? So if I wanted to store this, 100, and this, I'd have to make a new map that was an integer string map, not a string integer map. Yeah.
I'm only confused with the key though, exactly. Does it kind of look like an index?
The key acts like an index, but like a general index. It's not a number, it's just a value of some kind. So let me use it once or twice, I think it'll be a little clearer. So I'm going to make a name ID map. So the name is the key and the ID is the value associated with it. And this is going to be a new hash map, which is an implementation of a map, a specific way of encoding the map. That's also a string integer. And I'm going to start off with an empty. And now I need to import stuff. Okay, so I'm declaring a map and assigning it a new hash map object. A hash is basically taking the internal values of an object and putting them through this sort of process that chops up all the bits and makes a number out of it. And that number basically creates sort of an index. That's roughly what's going on there, but we won't try to really explain it here. to use this, I can say put. So I'm not, instead of add, I'm putting in a new key value pair, an entry. So I'm going to put in David as the key and 100 as the value. So that would store this kind of combination here. Okay. Now the way, and let's do one more. Name ID map. Put Joe. And he's a value of 5. So I'm better than Joe. All right, so we'll put stuff into this map. Now normally in a list, to access it, well no, that's wrong language. We added it, and then we can get it, right? Or, so in this thing, we want to, let's do a print. Let's print out the ID for David is, and I'm going to print out name ID map get David. So I provide the key. Oops. I provide the key, and this evaluates to the value. So the value of this thing is 100, right? So this call, this method call here, would evaluate to the key, 100, because I'm getting the value associated with the key, and printing it out. So if I run it, maybe, okay. Whoa. Okay. So I'm not getting the value by index. I'm getting it by key, which is a total generalization kind of thing.
For the hash map, is there any way to specify what hashing algorithm we want to use?
So when you hash stuff, there's things where you can get conflicts with the same object, hash at the same place, and there's ways to resolve that. I don't want to talk about that right now. So the way to think of this, instead of an index like 1, I'm putting in a very general thing like David. Now there's no ordering to this. An array list has an implicit ordering by index. There's index 0, index 1, index 2, index 3, and you have some way that they're stored in that array. There's no guarantees for, well, there's some guarantees, but anyway, you shouldn't think of these as somehow one is better than the other in some sense. One is smaller than the other, one is or lower in the hash map. They're all just sort of floating in this cloud of this hash, and you say, is there a David thing? Yes, it's 100. Is there a Joe thing? Yes, there's a 5 associated with it. All right. Now I can remove a value. By the key. So I can say remove the entry associated with David. And now that whole David 100 thing is gone out of that map. Okay. I can also ask if the map contains a key. So if name ID map dot contains, what's trying to help me there, dot contains key of David, then I can do something with it, like found David key. That's not doing much with it. It shouldn't print anything because I removed David. Okay, so I removed David, so I didn't find it. If I said remove Joe, then we found the David key. Okay. Now, sometimes the problem is you're given, let's say you're given a map and you want to do something to all the things stored in it. The problem is you don't know really, well, there's no way immediately knowing what keys are already in there. So in an array list, we know sort of the index values that are allowed because we can ask for the length of the array list, and we go from 0 to 1 minus that size, and that tells us all the indices that are valid for that array list. But here, unless I know in advance what the keys were, David, Joe, Sally, Frank, I have no way of sort of just saying, like, give me all the things. So there has to be a way of doing that where I can kind of go through and get to these values. But let's say, if I wanted to print out the map, like all the entries in it, I need some mechanism to loop over all the entries. But I can't just stab random names, like generate random names. Hey, is Joe in there? Yeah. Is this name in there? Is I could randomly make up keys and see if they're in there, but that's a very inefficient way of figuring out what things are in there, right? Because it's sort of an infinite number of them. So we need some other mechanism for processing all the things in a map. And the way we do that is to look, there's a way to get all the entries. So the entries are the pairs in there. So let's put in one more one to make it a little more interesting. All right, Aaron, 25, and I'm not gonna remove Joe. All right, so there's David, Joe, and Aaron in there right now. I'm gonna do a loop over all the entries. So again, one pair here is called an entry. And in fact, that's the name of the type that it has. So I can make an entry that is a string integer entry and loop over the name ID map and its entries. Entry set. That should work. Why is it not working? Type mismatch. String integer to. Oh, I think it's just that this is not imported. Okay. So this is a little mysterious, right? So first of all, we've been doing these little for loops where we give some like array list here, and it puts it one at a time into this variable here. Spell it out, entry. In this case, it's the same thing, except this is not an array list. It is a map, and we're getting sort of a list of the things in the map through this method call. Okay? So this will return all the different entries, and I can loop over them one at a time, and then I could print them out. System out. Entry. And let's print out the entry, the key, get key, and the entry value, get value. So this is an alternate access, essentially, to the map besides saying, what's the thing at David? What's the thing at Joe? What's the thing at Aaron? Instead, I'm saying, just give me all these pairs, and I can pull out the values and see what the key looks like and see what the value looks like. So found 3 entries, Joe, Aaron, David, and printed them out. All right, so that's sort of a complicated structure. They're actually super useful. So again, instead of sort of trying to associate an index number with a thing, here we're associating something more general with a thing. And so you'll find, when you start using them, you'll find all sorts of uses for them.
So with your for loop, if an entry is put in where it's like in a different order, like integer string or some other entry, what would happen with it? Or something?
So that's the whole thing with generics, right? It's like they're flexible, but not that flexible. You have to say what kind of thing that generic is when you're using it. So in this case, we had to say that we know these pairs are string integer values, and if I made that something else, it would just complain about it and say, here, type mismatch cannot convert from a string integer to an integer string. And you'd realize that you need to kind of fix that up.
I guess, can a map hold more than one value in there?
So we're holding a David 100,
like
Joe 5.
For each key, could I hold a value, a value, a value?
So no, if I put in something David 1000, it would overwrite. I mean, it's like an array list. At that index, it holds one value.
Okay, so I guess at each value, can that value thing you send in be an array of values, like?
Well, if I define that to be a string and an integer array, I could do that.
And then we know that, like, for instance.
So you run a whole bunch of
X1
things.
is my age, and X2 is my.
And there also, actually, there are variations of these maps that are a little more flexible in terms of multiple values, but again, they're sort of variations. So, holds one thing per key here, and if you change that relationship, it just overwrites it. Now we can use this to solve our voting problem. That's why I went down this path, right? So we're going to have orange as the key, apple as the key, and some kind of vote count as the map. So if I'm I can go through and say, hey, does my map already know about this label? Orange or David, wherever it is. If it does, that's a vote for it, right? So if we go back on our list here and say, we have an empty map, and say, does orange exist in the empty map? It does not. So let's add it to the empty map with a vote of 1, because that's one vote for orange. If we see orange again, we say, does orange exist in the map? It does exist in the map. So let's add 1 to the existing count that's stored in there. So here, if it already knows about a label, then we're going to put at that label the old value associated with it, the get, plus 1. Right? So we take the old vote, add 1 to it, and put it back in under David. If it's the first time we see David, then there's 0 votes for David, but I'm putting it in because I found a vote for David, and so we put it in with a vote of 1 to start things off. All right, so again, this is a little, you have to get used to map. I think this whole thing of adding and starting at 1 is weird. We're used to initializing things at 0. But if you found a David, I get a vote. If you find another David, I get another vote, right? So vote for me.
So when we're putting, we're not, are we overriding the David?
It says at this key, exists or not,
Okay.
put this value.
So if it exists,
If it exists, it overwrites it. If it doesn't exist, that's it.
oh,
To pick a winner, we need to iterate over all those entries like I just did to print out the values and look at the values associated with each one. And then it's really just an optimization loop like we did several weeks ago. We're trying to find the maximum value, the maximum vote count. All right, so you know how to do that. Once you get that, you know how to classify your whatever it is. All right, so I need to just clean up a little bit of code. What's going to happen is I'm releasing a fake assignment right now. It has no due date and no way to submit anything. This is just to help you get started. I want you to form partners if you want to form partners. I want you to start looking at this KNN code. You're basically going to finish the implementation of the classifier, doing some of this map stuff. All right? But I just told you how to do it, so it's not really that hard. On Monday, like it really isn't that hard. On Monday, I'm going to talk about drawing stuff on GUIs because I want to do some fun, like clicking on things and drawing circles and lines and things like that. And we're going to basically see how the KNN classifier works visually as opposed to just seeing numbers spit out. And that'll be the real assignment. All right, so that's, I'll send out an announcement when I release the code. I'm sure you're all dying to get going.